Okay, acid nomenclature is a little more difficult than covalent nomenclature. Actually, it's a lot more difficult. It is one of the hardest kinds of nomenclature we have, just because acids are a little strange and they just have these rules. There's all these rules, you have to remember them. It's not too bad. There's only 3 kinds of acids. An acid is any type of compound that starts with hydrogen. So hydrogen is acting like a cation here, and then we have some sort of anion going within. That anion can be either an element or it can be a polyatomic, and then hydrogen would have some subscriptives it needs to in order to balance the whole thing out. So to name acids, the first thing you do is ignore the hydrogen. Because all acids have hydrogen, we don't include hydrogen in the name. So we don't call this hydrogen acetate. It's the hydrogen, the fact that it has hydrogen will be noted later when we talk about the fact that it's an acid. Next, you have to classify the anion. Is it is it an element? Is it a polyatomic? If it's a polyatomic, does it end in ite? Does it end in ate? You have to decide this. And then you're going to change the ending of the anion and add the word acid, according to this table. So if your anion is an element, then you are going to put a prefix of hydro in front of it. You're going to change the ending of it to ic and add the word acid. So let's try this one. If we have hydrogen and chlorine, we're going to ignore the hydrogen, so what we have left is an element. We can tell that because there's only one capital letter there, and that element is chlorine. So we're going to take the word chlorine. We're going to add a prefix of hydro, and we're going to take the ending and change it to ic. So instead of ene, it's ic, and then we add the word acid. So this is hydrochloric acid. If your anion is a polyatomic, it could be a polyatomic that ends in ate, or it could be a polyatomic that ends in ite. If it's a polyatomic that ends in ate, then you change the ending to ic and add the word acid, but you do not put the hydro prefix. So if we take this one, we ignore the hydrogen, what we have left is a polyatomic. That name is called chlorate. We don't put any prefix here, and we change the ate ending to ic and add the word acid. So this is chloric acid, as opposed to hydrochloric acid, which is the element. All right, the last possibility is that you're a polyatomic that ends in ite. In that case, you change the ite to us and add the word acid. For example, this one. We ignore the hydrogen, we have a polyatomic left. That polyatomic is called chlorite. So we change that ite to us and add the word acid. The word acid indicates that there's a hydrogen there. So we don't have to name the hydrogen because when we say it's an acid, we know that there's a hydrogen because that's the way that acids are. All right, so let's practice a few of these names. So first we have this one. Again, ignore hydrogen. What's left? Well, that's clearly not an element. We've got 3 capital letters there, so that has to be polyatomic. Then you're racking your brains trying to remember what that polyatomic is. Never forget your polyatomic ion list. You'll never get to use it on a test. You'll need to know for the rest of the year. This polyatomic is called acetate. So we're going to change the ending. If it's an ate, we're going to change it to ic. And add the word acid. So this is acetic acid, which happens to be vinegar. Vinegar is a dilute version of acetic acid. All right, next one. We ignore the hydrogen. It does not matter that there's 3 hydrogens. Ignore them all. 3 is only there to make the charge balance out to neutral. So what we have left is an element. The element is called nitrogen. So we're going to put the prefix of hydro. An element, we need hydro. Then we add the root nitr. But instead of ogen, we're going to put ic and add the word acid. So this is hydronitric acid. Last one here for the naming. Ignore the hydrogen. Polyatomic, capital letter here, capital letter there. This is an L, not an I. It's never going to be Ci, it's always Cl, chlorine. So this polyatomic is hypochlorite. Because it's an ite, we're going to change the ending to us and add the word acid. So it becomes hypochlorous acid. All right, let's go the other way. Let's name, we have the name and we need to write the formula. So we have this name, and I'm looking at this name and I don't see a hydro here, so that tells me it's not an element. And I see an ic there, so that tells me that it's a polyatomic that ends in ate. I don't care about the word acid because I know that it's going to have hydrogen. So let's find the polyatomic that starts with this and ends in ate, so I have a perchlorate. perchlorate, ClO4. Perchlorate is a -1 charge. Hydrogen's always the same, the +1 charges. So we're going to need one, if this is -1 and hydrogen is +1, we only need one hydrogen. So the formula is HClO4. All right, let's try this one. I see a hydro there. That tells me it's an element. The element is this one, phosphorus. So here's phosphorus. We're going to have a hydrogen. Now we got to figure out how many. There's -3 here. This is +1, so I'm going to have 3 hydrogens there. So the formula for this is H3P. Last one, sulfurous acid. I don't see a hydro, so I know it's a polyatomic. I see an us, so I know that it's an ite polyatomic. So it's a polyatomic, it starts with sulf, and ends in ite, so we sulfite. For the acid, we just add back the this is just kind of a make it sound right kind of thing. So sulfurous acid is based on sulfite. We also need the hydrogen. Sulfite has a -2 charge. Hydrogen is still +1, so we're going to have 2 for the hydrogen. So it's H2SO3. We're going to do more practice of both ways, naming it and writing a formula of it in class. Thank you, and have a wonderful Thanksgiving.